This video is part 2 to section 7.3, Division of Polynomials and the Remainder and Factor Theorems. And for this video, we're going to be focusing on synthetic division. In the last video, long division will work for anything, but synthetic division, we need to read this little statement. It says, synthetic division is a very efficient way to divide a polynomial as long as the divisor is of the form x minus c for a variable x and a constant c. So we really need, I'm going to highlight it so it stands out, we really need it to be of the form x minus c. If it's not, you have to use long division. All right, so this first box just says use synthetic division to divide. And so what we're going to do is we are going to take x minus 5 and set it equal to 0. And when I solve for x, I get 5. There's going to be a pattern here that it's always going to be the opposite sign of what's in the factor. So this one is 5. So you don't need to solve that little problem every time, but for this first time, I just wanted to show you where we get that. And then we're going to be doing kind of like a little trick here. You'll draw this little table to help us stay organized. And this first little shelf is what I'll call it, but we're going to put our 5 in the shelf. And then on this top row right here, we're going to put all of the coefficients. So we have a 2x cubed, a negative 11, x squared, a 9x, and a negative 20, and we're going to put those on the top row. So when we do that, that's going to look like 2, negative 11, 9, negative 20. Okay, so when we start to solve this problem, you're always going to drop the first number. And then to get our next number, we're basically going to alternate between multiplying and adding. Okay, so when we do that, if I multiply, I'm going to multiply 5 times 2. So multiply 5 times 2, and that gives me 10. And then I'm going to add down, and that gives me negative 1. We're just going to repeat that. Let me erase so it stays organized. Okay, so we're going to do the same thing for this next box. We're going to multiply 5 times negative 1. So I'm going to put a multiplication sign there, and that gives me negative 5 right here. And then I'm going to add down. 9 plus negative 5 is 4. Let me erase to stay organized. Great. For our last box, we're going to do the same thing. 5 times 4, and that gives me 20. And then I'm going to add down, and that gives me 0. Awesome. So just like with long division, we have a remainder, and the remainder is always going to be what's left over in that last box. So for this one, our remainder is 0. I'm going to label it just so you can see. Okay, so if we want to go back and answer our question, it says use synthetic division to divide. This 2, 1, and 4 is going to, or negative 1 and 4 is going to be our solution. However, we need to go back and put variables back in. And if you notice here, we were given x cubed and we divided out an x. So this next, so when we divide out an x, we're going to be left with x squared from x cubed. So that's a little confusing, but basically you're going to take 2x squared minus x, you could put a 1 there if you wanted to, plus 4. So this right here is our answer. So we saw that, okay, we started with an x cubed, we divided out an x, so I know that my polynomial solution is going to have an x squared in it to start. Oops. Okay. Let me get that all cleaned up. All right, for the next one, we're going to do the same thing. Here, we're going to plug in x equals negative 2. I'm not going to show my work, but hopefully you understand how we get that. And then I'm going to create my little table. My negative 2 goes on the input shelf. And then along the top, I'm going to have 5. And then I'm going to put a 0 because if you notice here, we go from x fourth to x squared. And so we need a placeholder for 0x cubed. Okay. So let me, I'm going to highlight that so it stands out. Hopefully in your notes you'll somehow make that stand out too, so you can remember to put the placeholder. Then I have 2x squared, negative 15x, and minus 10. Okay, so we're going to drop the first term. To get our next term, we're going to multiply negative 2 times 5, and we get negative 10. I'm going to add down, and I get negative 10. I'm going to multiply negative 2 times negative 10, and I get 20. I'm going to add down, and I'm going to get 22. Multiply negative 2 times 22, and I get negative 44. I'm going to add down, and I get negative 59, I think. Yep. And I'm going to multiply negative 2 times negative 59, and I'm going to get 118. I'm going to add down, and I'm going to get 108. And just like last time, this last box, we can square it off because this is our remainder. So for this one, the remainder is 108. And then I am going to go back up here and label this as the placeholder for x cubed. If you don't put that there, that you're going to get the wrong answer. It's going to mess up your math. Okay, so we need to write out our answer. We can't just leave it as a table. So notice here we started with x to the fourth and we divided out an x. So we're going to start with x cubed for this one. So when we write our answer, we're going to have 5x cubed minus 10x squared plus 22x minus 59. This time we have a remainder, so plus 108. And our remainder is out of what we divided by. Just be careful, it's not negative 2 for this. It's going to be what we divided by x plus 2 here. So our remainder is plus 108 out of x plus 2. And this right here is our answer. So this one does not divide perfectly like the first one. Great. All right, this next section, it says remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is f of c. So just like up here, we have remainder of 0 and then 108. This says that if you plugged in c, here, then our remainder would be the function evaluated as c. All right, so given f of x equals x plus x to the fourth plus x cubed minus 6x squared minus 15 or minus 5x minus 15, use the remainder theorem to evaluate. So if I have 5x, or sorry, I cannot talk, sorry, f of 5, that means I'm going to plug in 5 for x. So I'm just going to do all this in my calculator, but what that would look like in the calculator would be 5 to the fourth plus 5 cubed minus 6 times 5 squared minus 5 times 5 minus 15. Let me move that over. Okay, and I'm going to take a second and type that in. And I got 560. Okay, we'll talk about what that means in a second. Let's go ahead and do the second one. So we're going to have negative 3 to the fourth plus negative 3 cubed minus 6 times negative 3 squared minus 5 times negative 3 minus 15. Be very careful with the negatives. You really need to utilize the parentheses in the calculator or it's not going to compute correctly. So let me take a second and type that in my calculator so I don't make a mistake. And when I do that, I get 0. So let's talk about what that means. By the remainder theorem, it says that when you plug in c, then the remainder is f of c. So what that means is if I divide f of x by x minus 5, because notice here in the remainder theorem it's minus c. The remainder will be 560. Okay. On part B, if I divide f of x by x plus 3, because it's the opposite, the remainder will be 0. Okay, so that one divides perfectly. So going back to these two, here we got a remainder of 0, and it factored perfectly. Here we got a remainder of 108. It did not factor perfectly. All right, factor theorem. So let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x, that's what we had here. Okay, we got a 0, so that means it was a factor. If x minus c is a factor of f of x, then f of c equals 0. So it's basically saying either direction will work. Okay, so use the factor theorem to determine if the given polynomials are factors of f of x equals 2x to the 4th minus 3x cubed plus 10x squared minus 25x and plus 6. So we need to set these equal to 0, and you could probably do this in your head. I'm just going to show for the note's sake. So if our factor is x minus 6, we're going to use the factor theorem to determine if x minus 6 is a factor of the given polynomial. So I'm going to use synthetic division with 6. And along the top, I'm going to have 2, negative 13, 10, negative 25, and 6. I don't need any placeholders because I'm not missing any terms. I'm going to bring the first term down. I'm going to multiply and add, multiply and add, multiply and add, multiply and add. And remember, this last one is my remainder. So because f of 6 does not equal 0, we know that x minus 6 is not a factor of f of x. Let me move that over a little bit. But because f of 6 is not equal to 0, we know that x minus 6 is not a factor of f of x. All right, let's do the same thing on part B. Really quickly, you should be able to tell that we're going to be plugging in negative 3. When I use my synthetic division, I'm going to create my table. My top row is going to be 2, negative 13, 10, negative 25, and 6. I'm going to drop the first term always. And then after that, I'm going to multiply and add. I can't do that in my head, sorry. Multiply and add. I can probably stop here and say it's not going to work, but let's go ahead and finish this for the sake of the problem. Multiply and add. These huge numbers. Multiply. Let's see, sorry. And add. Okay, that last number is my remainder. Again, the remainder is not 0, so very similar to part A, because f of negative 3 is not equal to 0. We know that x plus 3 is not a factor of f of x. Unless I did something wrong. On both of those, I went really fast. I did expect one of them to be 0, so if you notice I made a mistake, please comment or send me an email or something. All right, factor f of x equals 20x cubed plus 39x squared minus 30x minus 2, given that 1/4 is a 0. So really quick, just off to the side, if 1/4 x is a 0, or 1/4 is a 0, we know f of 1/4 equals 0. So basically that's what that means. So when we plug in 1/4 into our table, we know this last box is going to be 0 is what that means. So along the top row, we're going to have 20, 39, -3, and -2. We don't need any placeholders. I'm going to drop my 20, multiply, and then add, multiply, and then add, multiply, and then add. So this one did factor perfectly. And so what we're going to have is we're going to have x minus 1/4, which looks really weird, okay, but we'll fix it at the end. And then I'll have 20x squared plus 44x plus 8. Notice here on the second one, we could divide everything by 4. Okay, and if I do that, I could pull the 4 out in front, and this will make everything a little bit prettier. So when I do that, I will have a 4 here, and then I'll have x minus 1/4 here. Oops. And then it'll make my second parentheses a little bit more manageable. So I'm going to have 5x squared plus 11x plus 2. Okay. This right here is not terrible, but it's a little ugly, so I'm going to put that 4 back into this other parentheses, and then I'll clean up the fraction. So when I do that, I'll have 4x minus 1 instead. It's just a little prettier. And then my second parentheses, I can factor this into 5x times x. I need to multiply to get 2 and add to get 11, so I'm going to put a 2 here and a 1 here, both with plus signs. And that is the factored form of the given polynomial. So let me put a box around this one. Okay. And then this last section says solve. F of x equals 20x cubed plus 39x squared minus 3x minus 2 equals 0. And notice that's the same polynomial given. So we can use our factored form. And we're going to use the zero product property to solve that. So what that means, if you don't remember, it says that we have 4x minus 1 times 5x plus 1 times x plus 2 equal to 0. And the zero product property says that one of these equals 0. So I could have 4x minus 1 equals 0. I could have 5x plus 1 equals 0. And x plus 2 equals 0. If we solve these for x, we're going to get x equals 1/4, which that matches what was given up here. It says 1/4 is a 0. And then for the middle one, I'd have x equals -1/5. And for the last one, I'm going to have x equals -2. Those are our answers.